Stonehenge is not what we thought it was. And I don't mean that in a vague, mysterious way. I mean the actual data, when you line all of it up together for the first time, describes something far more precise, far more deliberate, and far more technically advanced than the standard explanation has ever managed to cover. Let me walk you through what I understand. The basic facts first. Stonehenge sits on a flat chalk plain in Salisbury, England, about 90 miles southwest of London. The outer ring is made of massive sandstone blocks called sarsen stones. Each one is over 20 feet tall. Each one weighs close to 25 tons. They were moved from a place called Marlborough Downs, roughly 20 miles away. On top of those blocks sit horizontal stones called lintels, and the way those lintels connect to the uprights is not just stacking. They use mortise and tenon joints. That's the same kind of tight wood joint connection a furniture maker uses. Except here, it's cut into solid rock by people who, according to what we currently know, had no metal tools. That already doesn't add up cleanly. Inside that outer ring are smaller stones called blue stones, each up to 4 tons. And they came from the Preseli Hills in Wales, 140 miles away. No wheels built for loads that heavy, no cranes, no iron. Modern engineering teams using hydraulic equipment still find moving a single 25-ton block genuinely difficult. The accepted explanation has always been log rollers, ropes, earthen ramps, and generations of slow labor. And nobody argues the stones aren't there. They obviously are. The question that kept coming back when researchers started feeding all of this into an AI system was not how the stones were moved. It was why those specific stones were worth moving at all. That question turned out to be the right one to ask. The timeline makes the standard explanation even harder to hold. This wasn't one group of people with one plan who worked for a few decades. Construction ran in clear phases from roughly 3000 BCE all the way to 2000 BCE. First a circular ditch and bank, then 56 spaced pits, then the huge sarsen stones, then the blue stones placed, moved, rearranged, and then around 1600 BCE, the whole thing was deliberately shut down, not abandoned, shut down. That difference matters, and I'll come back to it. Now here's where the 2026 research comes in. A team assembled the most complete set of Stonehenge data ever put together in one place. Every survey, every geological scan, every astronomical calculation, every measurement produced across roughly 300 years of study. All of it. Then, they put it into an AI system with one instruction. Look at everything. Find what individual researchers, each studying their own piece, kept missing. The AI was told not to favor any existing theory. Just report what the numbers actually show. What it found starts with something everyone treated as background. The 56 pits. These are called the Aubrey holes. A ring of pits just inside the outer earthwork. First identified in the 1600s. For 300 years, they were treated as basically incidental. A few had cremated remains in them. Others were empty. The spacing between them was written off as the normal imprecision you'd expect from people working with basic tools. The AI measured the spacing between all 56 holes down to fractions of a millimeter. Then it mapped the distance between every consecutive pair around the full circle. What it found was not random scatter. The spacing follows a clean, repeating wave, a curve that matches, with very high accuracy, the equation that describes how the moon's orbit shifts across what's called the 18.6-year lunar nodal cycle. That's the cycle over which the moon's rising and setting points move to their extremes and back. The gaps between those holes encode the moon's maximum and minimum position across that entire period. To me, this is where it stops being just impressive and starts being genuinely hard to explain. This is not a sightline you could stumble onto by watching the sky on a clear night. Tracking the lunar nodal cycle means watching the moon's rising point shift slowly over nearly 19 years and recording every measurement accurately enough to capture the full curve. Western science didn't formally describe that orbital mechanics until Kepler in the 17th century. Someone encoded the same knowledge into chalk pits roughly 5,000 years ago, accurate to centimeters, across a circle 100 meters wide. The reason there are 56 pits also gets explained by the math. 18.6 multiplied by 3 is 55.8. Round that and you get 56. The ring is a triple-cycle lunar calculator. It holds 56 years of moon tracking, frozen into the spacing of holes in the ground. And think about what building that required. You would have to watch the moon's rising and setting positions across close to 2 decades. Record every shift. So hold all of it accurately enough to translate it into physical distances cut into chalk. That is not one person's work. That is a chain of observers passing measurements down across nearly a human lifetime before a single pit was dug. Then the AI turned to the standing stones. It took every measurement of the sarsen stones, their positions, heights, orientations, density, the exact curvature of the circle, how every lintel sits, and it ran acoustic simulations of the completed monument. The result was that Stonehenge works as a resonant cavity, a three-dimensional space shaped to control sound. The geometry forces standing waves at specific frequencies. The strongest of those fall between 95 and 120 hertz. That frequency range sits below conscious hearing. You cannot hear it in the normal sense, but your body responds to it. Research into that frequency range confirms it can trigger altered states of awareness, strong emotional shifts, visual effects, changes in heart rate, and neural patterns associated with trance-like states. The geometry of Stonehenge produces those frequencies when sound is made inside the ring. What I find significant here is that this is not a coincidence of shape. The precision required to aim a resonant frequency at a specific range and hold it there is the kind of thing acoustic engineers today achieve using heavy mathematics and computer modeling. The stone ring does it purely through geometry. An accidental echo doesn't aim. This aims. Then the AI cross-referenced the acoustic map with the archaeological record. The spots inside the circle where the infrasound effect would be strongest. The nodes where the sound field peaks. Those spots align with the locations where cremated human remains were found, not scattered randomly. Clustered on the exact coordinates the simulation flagged as the most intense points in the acoustic field. To me, that detail is the one that shifts the reading of this place most sharply. Those burials sit on the hot spots. Someone knew where the effect peaked and placed the dead exactly there. Now to the bluestones and why whales. The AI ran the mineral data on every bluestone. When you strike a bluestone, it rings. It produces a clear, sustained tone. Different stones ring at different pitches depending on size, shape, and mineral makeup. The analysis found that the bluestones were not chosen randomly from a Welsh quarry. They were selected to build a harmonic series. Tones locked together by precise mathematical intervals, forming a 5-note scale. The same 5-note structure appears in ancient musical traditions across cultures that had no contact with each other. What this means is that someone stood in a Welsh quarry, struck individual slabs, listened to the tone each one produced, and kept only the ones that fit the specific pitches the design required, then moved those particular stones 140 miles. That is not blind devotion to a sacred place. That is quality control on a precision instrument. The placement inside Stonehenge is equally deliberate. Each bluestone sits on a specific acoustic node relative to the sarsen ring. When the outer sarsen stones generate the low infrasound resonance, the bluestones at those positions vibrate in response. The outer ring produces the fundamental tone. The bluestones add the harmonics on top. Together they build a tuned acoustic environment, designed specifically to affect the human body. Then, the AI widened its view to the surrounding landscape, and the frame changed completely. LiDAR surveys, geophysical maps, and archaeological records covering several square miles around Stonehenge were fed into the system. Stonehenge is not a standalone monument. It anchors a connected network. Hundreds of earthwork enclosures, burial mounds, ceremonial paths, timber circles, pit lines arranged by geometric and astronomical relationships. The AI measured and confirmed. From the ground, it looks like unrelated sites spread across a landscape. From the pattern the AI identified, it is one coordinated design, drawn at a scale no person standing on the ground could perceive while drawing it. Some burial mounds form precise geometric triangles with Stonehenge at the apex. Earthworks run straight for kilometers. Timber circles mark specific astronomical events when viewed from the monument. The surveying precision needed to place structures kilometers apart and hold the geometry accurate to within a few meters is the kind of precision we typically associate with classical Greece, nearly 2,000 years after Stonehenge was built. The landscape data says the Neolithic builders had it anyway. Here is the part that gets uncomfortable for the timeline. Some of the earthworks wired into this geometry were built between 3,500 and 3,000 BCE. That is 500 to 1,000 years before the sarsen circle went up. The landscape blueprint existed before Stonehenge. The monument was set into a geometric plan that was already there. Somebody drew the master design around 3500 BCE and began laying it into the ground. Their descendants across 20 to 25 generations kept executing it accurately enough to finish the work, without writing, without any written record that survives. The AI checked that against what we know about oral tradition. Even the most stable traditions on record drift measurably across centuries. What this landscape requires is transmission tighter than anything documented in human history. Knowledge held exact and usable across 500 years. Then, the AI looked at the order in which the stones were actually cut and placed. And this is the detail I find most striking of all. The earliest arrangements are the most precise. The first bluestone layouts show the deepest understanding of acoustics. The first sarsen arrangements achieve the strongest resonance. And then it loosens. Later stones land in positions that weaken the sound. Later alignments drift. Technical traditions normally improve over time, each generation a little sharper than the last. Stonehenge does the opposite. It peaks at the beginning and declines from there. The numbers are specific. Early stones sit an average of 3.2 centimeters off the acoustically perfect position. Later stones miss by 12.7 centimeters. That gap is not sloppier execution. It is the distance between someone who understands why a stone goes exactly there and someone who only remembers that it should go roughly there. The first is knowledge. The second is a copy of knowledge that has thinned with every passing generation. The tool marks confirm it. Different working techniques appear on the same stones, separated by what weathering suggests are decades or centuries. Some blocks were partly shaped, set aside, then returned to, and finished by someone who clearly did not understand the first person's approach. Contact surfaces on the early stones show variation under 2 millimeters across 50-centimeter spans. That is a level of precision typical of precision metalwork, achieved in raw stone with stone tools. Experimental archaeology teams have spent months trying to reproduce it and arrived at rough approximations at best. The first builders achieved something their own descendants could not repeat. The AI confirmed 9 astronomical alignments built into the monument. The famous summer solstice sunrise alignment most people know about, plus 8 more that no prior study had formally identified. Lunar standstill extremes, stellar alignments that account for the slow shift in the Earth's axis, called the precession of the equinoxes. Cross-quarter day markers. 9 alignments total. Average error under 0.3 degrees. Several of them track cycles that take more than 1 human lifetime to complete. You do not build a 100-meter stone machine to remember when to plant crops. You build it for something that comes around slowly, rarely, and matters enough that forgetting it would be a serious problem. What those cycles were converging toward, the AI cannot say. It can see they were being tracked. It cannot read the reason behind the tracking. The final closure of the site, around 1600 BCE, the AI reads as something specific. Fallen stones were laid down carefully. Specific areas were deliberately covered with earth to protect buried features. The site was shut down in an orderly way. That reads like people who knew they could no longer maintain the knowledge needed to keep the monument running correctly, but wanted what they had built to survive for whoever came later, sealing it, trusting it to people they would never meet. To me, that is what the whole picture adds up to. This is not a monument built by people at the beginning of understanding. The data describes something closer to the opposite. A final record of knowledge, already ancient, at the time it was carved into stone, already in decline, preserved in the most durable medium available, because nothing softer would last long enough to carry it forward. The math is confirmed. The acoustics are confirmed. The geometry and the astronomy are measured and confirmed. What is not confirmed, what the data genuinely cannot answer, is where that knowledge came from in the first place, and what long period of forgetting happened before the people who raised these stones, while only partly understanding what they were building. The AI opened that question properly for the first time. It cannot close it. But for me, the main thing to take from all of this is this. Stonehenge was not a rough monument assembled by faith and effort. It was a precision instrument built by people who understood orbital mechanics, acoustic physics, and landscape geometry at a level that should not have been possible, given everything else we know about that period. And the most uncomfortable detail in all of it is that the people who built it were already losing the knowledge as they built. The monument is not the beginning of something. The data says it is closer to the end, so that is how I understand it now. Something very precise was built. The precision came from somewhere, and we still do not know where.